Okay, so in this video we're going to go over graphing a polynomial. Right, so up to now we've gone over multiplicity, zeros, finding x and y intercepts, looking at end behavior, turning points, etc. Right? Now we can put all that together to graph something like this, right? Without the use of a graphing calculator or some kind of graphing utility, which is, once we know all those and understand those parts, is really not that much of a challenge to do that, right? Especially since it's already in this nice factor form, right? If it isn't in a nice factor form and it's not easily factorable, then yeah, go ahead and use a graphing utility. But something like this, it'll probably take you more time to input this into Desmos or your graphing calculator than to actually do this by hand. Right, so right away we notice here that we have 3, there's 2 here, 5, and then this one is multiplicity 1. So we have a polynomial of degree 6. Right, and also this leading coefficient, right, is going to be negative, right? So I already know that the behavior is going towards negative infinity on both ends, right, due to the evenness of the degree. Right, so now with the zeros, looking at this, x equals 0 is one of the x-intercept. X equal negative 2, multiplicity 2. X equal 4, multiplicity 3. Okay, and then looking at this, when x is 0, our y-intercept is 0. So it goes through the origin, right? The y-intercept, let x be 0, right? Plugging in there, that means that n of 0 gives me 0. So it goes through the origin. All right, and again, like I said, the end behavior, this being negative, the leading coefficient, that means that I know the two quantities as x goes to infinity, in this case n of x goes to negative infinity, and as x goes to negative infinity, f of x also goes to negative infinity. All right, and I think we're pretty much there to go ahead and jump into graphing something like this, right? So I'll graph by first starting off my x and y coordinate plane. All right, so here, let's see, 1, 2, 3, 4. That should be enough here. 1, 2, 3. And here, 1, 2, 3. Okay, so label our axes. This is our x-axis. This is our y-axis, right? We have 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, all right. And then 1, 2, 3, negative 1, negative 2, negative 3. All right, so we know we have, let's mark off our zeros here. Let's switch up my colors here. So we know we have our 0 at negative 2, multiplicity 2, 0 at the origin, right? Both an x and y intercept there, and our final unique one here is 1 at 4. Okay, and again, knowing this, I know that it's coming from down here, right? Negative infinity, the end behavior, right? The local behavior, we have kind of plotted out here. So coming up from negative infinity, 0 at negative 2, multiplicity of 2. So what does that mean? That means that it touches it, comes back down. Right? Then I know that eventually, before it hits back to 0, it must cross the x-axis again. Now that one is multiplicity 1, so it just kind of goes right through, right, almost like a line. Right? And then it goes, increases, and then it comes back down at some point. And again, 4, and actually I kind of messed that one up here. 4 kind of tapers out, right? Not quite linear, kind of has that little flattening out, and then goes down towards negative infinity. Right? So it looks something like this. And that's it, right? That's a rough general shape of what the graph looks like. We notice here there are a couple of local max here, max, and then we have a global max actually here. All right, and a local min here, but no global min, right? Since this goes down forever towards negative infinity. Now, at this point currently with what we learned so far, we don't have quite the tools to determine where this global max occurs, or even the local min occurs. Later, when we get into a calculus course, you will possess those tools to find what those values are. Okay, but for now, we have this nice sketch made by just simply having a polynomial in factored form and understanding the ideas of end behavior and multiplicities of zeros. Okay, and that's how you graph a polynomial.